The other thing that I could look for as an attacker is files that have the setuid or the setgid bit set. What is the setuid or setgid bit, you might ask? In order to do that, let's take another look at file permissions. So I'm going to create an example file that I can play around with. I'll call it test.sh. And if I list that out, you'll notice that here I have this test.sh. So you might be already familiar with the different standard permissions that are associated with that file. For example, there's read, there's write, and there's execute. And there's separate read, write, execute permissions defined for the user who owns the file, the group that owns the file, and then everybody else. However, in addition to these, there are 3 extra bits, setuid, setgid, and the sticky bit, that also affect how the file behaves. Let's say I make this test.sh file runnable. I'll do that by adding execute permissions to the file, right? This should be familiar to you. If I print this out, you'll now see that everybody has execute permissions to run that file, so I can run it with /test.sh. When I run that file, or any normal file in Linux, it gets run with the permissions of the user who ran that file. So in this case, I'm user hacker. So when I try to run test.sh, it'll run test.sh as user hacker. However, there are certain cases where we actually want to run the file as a different user. One example is sudo. When we use the sudo command, we're actually using it to run a file as a different user. How does it actually go about doing that? Well, it needs the privileges to be able to impersonate other users. In other words, it needs to be run as root. If we take a look at sudo, I can see where it's located with which sudo, and then I can print out that file and its attributes and permissions. You'll notice something interesting about this sudo file, and that's that it has this S in place of X. This S is the setuid bit. And what the setuid bit does is it says whenever somebody runs sudo, instead of running it as the person who actually ran it, run it as the file owner. So in this case, because root is the file owner of sudo, whenever anybody runs sudo, it'll actually run that as root. So the process that gets spawned when we run sudo will have root effective permissions of root, right? The second thing you'll notice is that in Kali Linux, it's very nice, and it also highlights it for you differently, so you can very easily tell that this binary has the setuid bit set. We can actually set this on this test.sh file that we created by saying chmod u plus s, so that says the setuid bit for test.sh. And now if I print that file out again, you'll notice it's in red again. And again, we have that S here. This means that anybody now who runs this test.sh file will run it as hacker rather than as their own who they are. Hopefully that makes sense. Why is this potentially interesting? Well, if the wrong file has that setuid bit set, let's say that file is owned by root and has that setuid bit set, then when we run that file, or when we execute that binary, if it's executable, we can actually run it as root. So to find all of the files on our Linux machine with the setuid bit set, I can use find / again to search the entire file system, -perm -u equals s. So perm searches for a specific permission, u equals s searches for that setuid bit, and then I'll take any errors and redirect them to dev null so we don't see any errors. If I run that, you'll see a lot of different files that actually have that setuid bit set, and most of them need to have it set in order to function properly. However, there might be one in here That's somewhat unusual. Just looking through this, I see this user bin bash copy. So we might guess that this is a copy of bash. We can try this out by running the file. So if I say user bin bash.copy, you'll notice that it in fact does start bash. And so it is effectively a copy of bash. I'm going to exit out of this. But we also noticed that it has the setuid bit set. If we take a closer look at that file, so if I ls-lah user bin bash.copy, you'll notice that that file is owned by root and has the setuid bit set. So that means when we run this copy of bash, or when we run bash.copy, it'll actually run it as root. We can go back to GTFOBins, which we looked at before, and we could also use it to search for files like bash that can be potentially abused when they have that SUID bit set. So if I search for bash here, you'll notice that it can be abused, of course, if we can run it with sudo, but it can also be abused if it has that SUID bit set. So if I look at that and read through this, it basically tells me that if I run bash with -p, it'll actually run it with the permissions that that setuid gives it. So if I go back here and we see the setuid bit set and the file owner is root, then if I run this copy of bash with -p, it'll actually run it as root. So in order to do that, I'll say user bin bash.copy, and then I'll say -p. And now, if I say who am I, you'll notice that I am the root user. So that's another way of escalating using this setuid bit. How do we actually go about fixing this as defenders? Well, we can run that same command that the attacker ran to find files that have that setuid bit set. So if I say find /-perm -u equals s, redirect errors to dev null. Again, we see that copy of bash there that has that setuid bit set. From here, we might want to do some more investigating to see if it's actually required or if it's not. So if I say ls-lah user bin bash.copy, here we can identify that the owner is root and that it has that setuid bit set. The other thing that we noticed is if we look it up, so if we, for example, if we looked up user bin password and we see if it has anything associated with that setuid bit, you'll notice that it's not on GTFOBins. So that's a very good indicator that it's not going to be vulnerable just because it has the setuid bit set. However, if we search for bash, for example, you'll notice that bash does pop up and it has that SUID function there. So that's a good indicator that maybe we're not supposed to have SUID set on that binary. So what we could do to remove it is we could say sudo chmod u-s, so that's removing that setuid bit, user bin bash.copy. And now if we print that file out again, this time you'll notice that setuid bit is no longer set. And if we were to try to run user bin bash.copy -p again, this time I don't actually switch to root, I stay user, right? I stay as the same user I was before. I would caution you again when doing this, you don't know if maybe that file is needed by some program that's on your machine and that setuid bit needs to be set for it to work properly. So if you make this change and you notice that something isn't working, you can always set it back to the way it was before by saying sudo chmod u+s user bin bash.copy, and then it's back to the way it was before. In this case, I know that I don't actually need that file, so I can just get rid of it altogether. Again, I caution you against doing this in case There is a service that requires this file or that is reliant on this file, but if I wanted to get rid of it completely, I could say sudo rm user bin -copy. There we go, and now we have fixed the vulnerability. I can fully demonstrate that by coming back here as an attacker. If I try to run user bin -copy -p again, now it's no longer there. And if I try to look for files that have that setuid bit set, again, it's no longer there.